What's up? What's up? It's your man, Jimmy Chan. All right, so we're given a function here, and it looks like a quadratic function, and I got to figure out where is it increasing and where is it decreasing. So when I look at this, I see that this is a quadratic. And since the A is negative, I know that this is going to be a frowny face. All right, so it's going to look something like this. That means I'm going to have a vertex. Now, better yet, I know that from negative infinity to here, to that vertex, I'm going to be increasing. And then after that vertex, I'm going to be decreasing. So, again, it's that vertex that I need to know about. All right, great. So, to convert this into vertex form, I got to separate this, kick -9 out of the master bedroom and into the doghouse, because they just made me mad because they were being a -9C. So therefore, they're kicked out. However, I also need this A to be a 1, a positive 1. So this f of x is going to be, I got to pull a -8 out. So I'm left with an x squared. And that when I pull the -8 out of the -2, I want to become a positive, but now it's going to be 1/4 x. And then that -9 has been kicked out into the doghouse. Okay? So with that being said, I have to find a new c, which is b divided by 2 squared, which is equal to 1/4 divided by 2 squared, which is equal to 1/8 squared, which that is going to equal to, what is that? That's going to equal to 1/64. Yikes! More fractions. No! All right, so that means I have to add 1/64 here. Well, what do I need to do over here so that the equation is balanced? Well, again, I will have to look at that. And you're like, what are you pointing at, dude? You're pointing at dead space. No, I'm not. I am actually just drawing this right here because I need to figure out what the product of that actually equals to, right? What is -8 times 1/64 actually equals to? Well, that is equal to a -1/8. So since that's equal to -1/8, that means I'll have to add 1/8 here. Okay, that way these two actually cancel each other out. The -1/8, positive 1/8 actually equals 0, right? So that way it balances each other out. But I wanted this to be a perfect square, okay? So now I have to go ahead and factor this part, leave everything else alone. So that means my f of x is going to still equal to that -8. And when I factor this, that's going to be an x plus 1/8. Man, I'm so quick on factoring this ugly thing, ain't I? But if you do the work, you can be as good as I am. So now we got to look at this. What the heck is that going to come out to be, right? So let me take a look. So let me go ahead and put a little more work into this one. So this is -9/1 plus 1/8. Okay. So I need common denominator, so I got to multiply this by 8 and multiply this by 8, right? So what do I get here? I get -72, don't I? -72. -72 plus 1 is what? -71, and that's going to be over 8 because both of these denominators are 8. Okay, so that means I'm going to bring that down here of -71/8. All right. So with that being said, my vertex, when I compare this to f of x equals a times x minus h squared plus k, my vertex must be negative 1/8, comma, negative 71 over 8. Wow, such a nice thing there. Yay. Okay, so my vertex here is negative 1/8, comma, negative 71 over 8. Okay, so again, I'm looking for when or where it's increasing. So it's increasing from negative infinity all the way to here. Now, when I talk about negative infinity, I'm not talking about from the negative y infinity to here, right? That's what tells me it's increasing, because I'm going from down there to up here. It's telling me I'm increasing. So again, the y is telling me I'm increasing, right? Because, for example, when you go into an elevator and you go from the first floor to the third floor, right, it's not the x that's telling you that you're going from the first floor to the third floor, right? It's a y value that's telling you you're going from the first floor to the third floor, okay? That tells you that you're increasing, but it doesn't tell me when or where I'm increasing. And the elevator is nice because it's the same x value all the way up. Here, with a quadratic, your x value changes. So, in other words, when I'm looking at you on the escalator, you're moving from here to here, but on the way up. So I'm actually looking at the x value. So for increasing, I'm actually going from negative infinity to that x value, which is negative 1/8. And for decreasing, I'm actually going from that negative 1/8 until positive infinity, which is, again, my x values. Now this is going to be choice C. And there you go. I hope that helps. If there's any questions, let me know. Later on. Bye. All right, let's try that again.